Okay, in this video we're going to look at the shape of distributions, and it's probably just handier just to teach it from the book in this case. We can have three major shapes in our distribution. Okay? We can have a symmetrical distribution, positive skew, and a negative skew. If we look at symmetrical distributions, they're the ones that have a symmetry down the middle. Okay, so down the middle, same on both sides. Generally this is called the normal distribution, okay, where I suppose most of the data lies at the mean or at the center. This type of distribution happens kind of a lot of the time in nature. So things like if I take the heights of random people, well, most of the people will lie around the mean, but then there'll be a smaller number of people who will be really, really tall, and a smaller number of people who will be really, really small. IQ intelligence, again, most of us are in the middle somewhere, okay, around the mean, but there is a small few very, very smart people and a small few not so smart people. Positive skew then, okay. A positive skew looks like this. So most of the data will be at the start of the lower end, I suppose. A few types of data that would be like that, I suppose. It says here the number of people in a family, right? So, or the number of children in a family. So most people would have, you know, a small number of children, one or two, but then there is some people who would have a lot of children. And the age that it takes you to ride a bike, most people ride a bike when they're pretty young, so around here. Okay, a very small few would learn how to ride it when they're older. Alright, then we've negative skew, which is the opposite. So it's most of the data up at the top or the far side. Okay, and a good example of that would be the age people are when they get their first set of reading glasses. Okay, most of the people will be up here when they're older. Okay, a very small amount of people will get reading glasses when they're young. A higher amount will get them when they're middle-aged, but most of the people who get reading glasses will be up here when they're old. Okay. Lastly then, just two other things to look at. There's bimodal distributions. Now I know I did say there can only be one mode, okay, and that's kind of what we've learned. But in a bimodal distribution there are two modes. There are two high numbers in it, okay. Multimodal then, there might be, you know, like that. There might be some more. There might be another mode, 3 or 4 modes. If we look then at these types of distributions, so if we look at this one, A, we notice that the mean is in the middle here, and most of the data lies around the mean. Okay. So let's just say heights of people. Okay, most of the people are around the mean height. There's a very small few really tall, and there's a small few really small. However, if we look at this one, B, there's the mean, alright, but very few people lie around the mean. So let's take, I don't know, a basketball team. No, well, actually, we won't take a basketball team. Okay, for this, I suppose we could take an old-fashioned rugby team and their weights. Okay, not so much a rugby team now because they're all big. But if you went back to the 80s, you'd have two very distinct types of people on a rugby team. You'd have the really, really heavy people, which would be in the forwards or in the scrum, and then you'd have the really light, fast, I suppose skinnier guys, that would be in the backs. So this would be an example of their weights. Again, you'd have a lot of the guys really, really heavy up here. You'd have a lot of the guys really, really small and light down here. So you wouldn't have very many guys who'd be average. You'd have a lot of them that are really heavy and a lot of them really small. So you'd have very few people that would be actually on the mean. I suppose data set B would have a higher standard deviation and a bigger spread than data set A. Okay, so just before we finish, we look at these questions. Just to recap, I suppose, we can have data like that, that's symmetrical. We can have data like this, where most of the data lies at the start of the curve, and that is called positively skewed. Or we can have data like this, which most of the data is at the end. Okay, so let's say it'd be like more like this. So most of the data is up here, the top or the end, and that's negatively skewed. Okay. So let's just have a look at these questions and answer them. So the first one here, it's saying what is this type of data commonly known as? Well, it's symmetrical, and we know it as the normal distribution. This one here, we can say it's positively skewed because most of the data is here and very little of it is up here. Okay, we'll go through these questions. Which one of these distributions is symmetrical? Okay, so you would say C is symmetrical. Which distribution is positively skewed? He's saying A is positively skewed. Which is negatively skewed? B, because most of the data is up at the top. Which distribution is the most likely to represent this data? The weights of international rugby player. Okay, so the weights of international rugby players, I suppose now would look like that because they're all pretty big. Okay, so it would be negatively skewed. At the same time, as I said, back in the 80s, it would probably look more like, well, as you saw already, more like that, okay, because there was really, really light guys and then there was really, really heavy guys. But as of now, they're all big, so it'll be most likely negatively skewed. And which distribution best represents this data? The intelligence quotients in a large number of second level students. It would probably be the normal distribution, okay? Most kids would be of average intelligence, so they'd be here. There'd be a small number really clever, and there'd be a small number not so clever. Okay, that's it guys, thank you.